But we're just estimating. Do I think you can get it to the nearest tens place? Absolutely not. But I think you should be able to tell me that it's between 2 and 3. 2 plus means it's over 2, and I would assume under the next whole number. Otherwise, you would have said 3 plus. Why is it?
I get like you have the 2 away, 3 away. But
Yep. And if I average 2s and 3s, I'm going to get a number in between 2 and 3. I'm not going to get anything above 3, and I'm not going to get anything below 2.
Okay.
You have to get something in between them. Okay, so think about this on the next one. Make a data set. With 8 values that has a mean of 10 and a standard deviation of exactly 3. Think about what we just did. I want the average to be 10, but I want the standard deviation to be 3. Standard deviation is the distance away from the mean. And you can kind of think about this last graph. It might help you come up with it. Dylan's got it. Anybody else want to think about it before he tells you? 13s and 7s. Why are you going with 13s and 7s? They're each 3 away from the mean. So how many of each would you need? 4 of each. So you would need 4 7s and 4 13s. Would a graph help with that? For some of you? I don't know. If this is 10, I want that to be my average, so I know to be the average, it's got to be the middle of my data set. I want my standard deviation to be exactly 3. So that means I want numbers that are exactly 3 above. That brings me to 13. And then 3 below. Does that help? And I got to have the same amount. That was simple. I think some of you might have tried to do this one on Friday and didn't have a clue. Okay, the next thing is a big graph. This is what I'm drawing. I just want to show you the size of it so you can, because we're going to be putting numbers in here and all this good stuff. So draw it kind of big. Draw big. I get yelled at because I didn't usually show that. What? Oh, not many. We're just about done. Okay, what we've got next, it ties into standard mean and standard deviation, is the empirical rule. Very, very powerful rule in statistics. It's called the 68, 95, 99.7 rule. That's what I called it anyway. Okay, and this only works for symmetrical data. Only for symmetrical data. Is all data symmetrical?
No.
No. Is a lot of our data in our real world symmetrical? Yes. Lots of it. So, we are going to look at how this data gets chunked up. The frequency graph. I mirrored my ink. I'm going to write below, yeah. I'm going to put everything below. Or you could write it above. I'm going to go everything below. Okay, where are we going to find the mean on this graph?
Right in the middle.
Right in the middle is going to be our mean. Now what the empirical rule does is it chunks the data up into 3 standard deviations above and 3 below. And that will, and I'll show you here. So kind of estimate what I'm doing. If I go 1 standard deviation above, that's about here. So this, on a number line, this would be the mean plus 1 standard deviation plus an S value. And then if I back up the same amount from the mean, this would be the mean minus 1 standard deviation. In between those 2 chunks, we would have about 68% of our data would fall within 1 standard deviation of the mean. Very important piece of information. So within 1 standard deviation, 68% of your data are going to fall in there. If I go another standard deviation above the mean, so if I kind of just use this spacing here, it's about 95%. So this is the mean plus 2 standard deviations. Oh, I forgot to put my percentages in, and we'll go back. This is the mean.
X plus what?
2S. 2 standard deviations. I know, the S's are bad, but I have to go with it. I try to stay away from them. The mean minus 2, yes, standard deviations. I'll try to make them better. S's. I could do that too. So what percent of our data do you think is in those 4 chunks?
95.
It is 95. 95% of your data is going to fall within 2 standard deviations of the mean. I want to go back because I forgot the individual percentages in here. 95. So let's go back to the first 2. There was 68% from here to here. What does that put in each one of these since it's symmetrical?
48.
How about 34?
34, yeah, sorry.
Yeah, 48. Where'd that come from?
I said 38, but...
Oh. So that's where the 68's coming from. If all 4 of these add up to 95, could you figure out these 2 pieces out here?
Yeah.
How? 95 minus 68,
27.
divided into 2 pieces.
13.5.
There's 13.5% in each one of these pieces.
Did I write that time?
And then, what do you think the 99.7 says about this? Yeah, but what am I going to do? Go how many standard deviations above the mean?
3.
3. That'll take you right to where it kind of tails off, gets real close. Is there going to be data past this 3rd standard deviation?
Yes.
Absolutely, just not very much. So this is the mean plus 3 standard deviations. And then the mean minus 3 standard deviations. So if you do, what have we got? 99.7 minus the 95, that's what? 2.7, cut in half.
1.35.
Well, sounds like 1.35. No, I got 2.35. Why is that? Did I subtract wrong?
99.7.
Oh, I did 97. Oh, yeah. It's 4.7.
That's 2.35.
That's 2.35. That's what I did. Put a 7 where I didn't want it.
You darn diddly screwed me up.
Okay. And yes, there's 0.3% divided evenly out in these tail pieces. IQ scores are normally distributed. You got to be way up here to be in that genius category. All right, so let's take a look at one. Let's see. Height.
I know.
This is it. Of American women
Okay, Dylan.
are
And
symmetrical.
what's Islamic Olivia?
She's Canadian.
Uh-huh.
Seriously, she was born in Ontario.
No.
Yeah.
With,
That's not true.
It is true.
No, it's not.
Yes, it is.
you know what the average height for a woman is in the United States?
5'4".
7.
5'4".
Well, I'm probably
5'4".
Told you.
That's 64
What's the
inches.
thing that's way off the wall again?
The outlier.
The outlier. You're still gonna be within the 99.7% of the population. Okay, 64 inches is 5'4".
I'm 7'3".
WNBA.
Standard deviation, 2.75 inches. Okay, I want you to make the graph and show the 7 key values, and then I'm going to ask you some percentage questions. So this graph does not have to be as big.
Wait, how old is this data?
This is real. This is not
Sorry.
outdated. Even though it's
It's
old data, it's still, because we haven't changed that much. I don't think this average height has changed over time. Okay, it says that it's symmetrical, and there's 7 key values: your mean, height, and then your 3 standard deviations above and below that contain 99.7% of our population. I guess I could have made it slightly bigger.
Are we going to write a lot in it?
Just the numbers underneath here.
Yeah, maybe it's the size.
I'm going to turn it sideways when I write them.
What?
So, what value should I start with if I'm going to make these 7 values? Where's 64 go? Right in the middle. Here's my average height, 64. There I am. That's me. Right? Actually, just a hair below. I'm 6'3.5". I'm almost done. All right. How do I get this next height value?
Subtract or add 2.75.
Add 2.75. What's that going to bring me to?
66.7.
How many of our class are in this chunk? Girls. Anybody?
Wait, how tall would that be?
That's 5'4"
34%.
to 5, almost 5'7", just shy of 5'7".
34%.
Nobody's in here?
Oh, that's
Well, that's you. 5'4" to 5'7", that's 5.
Oh, that's you.
Oh, see, there we go. There we go. Now we're all coming around. Next one. Next one. How do I get it?
Add 2.75.
Add 2.75 again. What's that going to bring me to?
9.9.
69.5. And the third standard deviation? 72.25. Did you stay on our graph there, Kelsey?
Wait, what is 70? I can't do math right now.
72 is 6 foot.
6.25.
I'm under.
Yeah, see, you're in. Where are you at, right? Are you in the second standard deviation? What are you?
I'm really close to the last one. I'm 5'11".
You're 5'11". Oh, see, you're up. You're out here. You're almost. You're over 2 standard deviations above the mean. Okay. How do I go backwards?
Subtract 2.75.
Subtract 2.75.
61.25.
61.25. Next.
58.
Oh, 58.5. I guess I could have thought first. 58.5.
It doesn't look like you messed anything up.
And the last one?
55.75.
55.75.
Wait, so what's the shortest one?
That is, how tall is that?
4, 7, and 7 3/4.
4, 7 and 3/4 according to Dylan.
Oh, there's definitely. What about Polly?
No, she is not 5 feet tall.
You do not think so?
I don't think so.
I'm not 5 feet technically.
I don't think she's 5 feet tall.
Wait, who's not 5 foot?
Melissa Polly.
Who's that?
She's a little itty bitty girl on the
Yeah.
basketball team.
Yeah. But she's still growing technically, isn't she?
Yee, girls don't grow up. When is the last time you grew?
This year.
How much?
I was freshman year. I was like 5'4". I was average height freshman year.
Really?
Well, okay.
I
maybe
think
not
I was done
average.
growing in about 8th grade. Done. Maxed out. Okay. Couple questions. What % of women are between 58.5